2-stage Thrifty Bot-esque cascading lift. We're doing a 3-stage continuously rigged belt-driven lift. I tried to copy. The main thing I tried to avoid is trying to do in-tube belting, because that is often extremely complicated and often requires very special bearing blocks. So either like custom, or I think other teams have used SDS bearing blocks. And we have Rev hardware, and I would rather just use the Rev hardware and try to deal with this style of lift. So in 2023, Spectrum did a very similar lift. They only had a 2-stage lift, but there was the same idea of having belt on the outside connected by various pulleys. And yeah, so we would basically have a Neo with a whatever gear ratio we decide to pick, driving a big pulley, and then these are essentially just idlers. I mean, we can have a look at it here. What's this? So essentially what this is just 2 3D printed parts with bearings on either side, a little spacer, and then through bolted. A big issue that Spectrum had was they said a lot of their pulleys failed, but it wasn't the pulley themselves. It was more, they used like shoulder screws instead of having through bolts. So they didn't show any pictures of it on their build blog, which is weird. But to my understanding, it sheared because of the point where the shoulder is, where it becomes really thin and becomes really weak and just snaps. And so instead, we have it through bolted with 2 bearings on either side. And then the way it terminates on the carriage is basically the same as Spectrum does it. They have this plate, which is just a Vex Pro plate with a hex shaft. Basically, the belt would wrap around, the belt would be, we would drill a hole in the belt, which would then, we would tap into the hex shaft, and then we would have a wrench down here that tensions it. Or we would have a ratchet wrench that is in between these 2 bearings that would help tension it, so we can easily keep the belt in tension between matches. Down here, what they did was zip ties. So they would drill holes in the bearing, or drill holes in the belt, and then zip tie it to this plate. I don't know how I feel about that. I think it would be safer if we did screws, just because zip ties can be hit or miss. But again, that's a detail that we can figure out later. Another upgrade that, or another change that we made was adding an active pivot. So what we have here is a live axle max spline that uses max spline bearings and shaft collars. And we would just have a max planter. Right now it's floating, but we would have obviously spacers and then screws coming through the bottom to mount it. And then, which would be driving a sprocket here with a through-bore encoder, which is then connected to a max spline sprocket. It is only driven from one side, which is unfortunate. I think there's probably a way to do it, to drive it with both sides. But I think this is a good idea that we can fall back on if we can't find a way to do it. It's just tough because this is just really tight. Because we have an added stage, the carriage becomes extremely tight because we need more space. I actually had to widen the lift by 2 inches because the initial geometry of it wasn't wide enough to actually package the end effector as it was supposed to be packaged. And this was like just the right enough amount of space. So yeah. So with that, I had to make the drivetrain also 2 inches wider. So right now we are at a perimeter of 118. We're actually really close to our competition drivetrain dimensions. I think we're just a little bit wider and the same length. And yeah, that's the 2 big changes that we made. Sorry? The same bumpers? No, we would have to make different bumpers because the change is enough to where we can't just throw on our off season or competition bumpers. I did CAD out the bumpers. I just did it basically the exact same way we did this year since it worked well for us. So I guess we'll go here. And yeah, also the whole idea of this robot is to upgrade it to where we can go faster and we can score in the barge. So that's why we needed an extra stage. So I have a detailed bumper assembly, and then we would just mount it exactly like we did this year with Southco latches and striker plates with 3D printed mounting. Yeah. You want to look at it with the game elements. So we can see here we have like a lot of space. This isn't close to full extension, and we still have lots and lots of space. So we should have zero problems reaching L4, and so we should be able to go 1 through 4. And then with the barge, we make it there. The active pivot allows us to make it so the elevator doesn't have to actually reach all the way and go over center. It can. So there's actually a bit, but okay. The computer is a bit slow right now, but the active pivoting end effector allows us to make sure that we can actually outtake the algae and score it into the barge. And then the climber and the intake is all the same as it was on the first iteration. And here's a full robot look. Yeah. We also had to make a cutout in the belly pan because of the way we had to put the motor. We would have to make another cutout in the belly pan so that the motor actually has space to mount. Yeah. I think that's all the changes that I made. The biggest thing was just lift, the end effector, and the slightly widened drivetrain.
Have you thought much about the lift dimensions on climbing?
What do you mean? What do you mean?
Have you checked with other teams? I know you were looking at spectrums. Like, how carefully have you verified the measurements for climbing with the design you have?
I tried to look pretty close. It was just Spectrum stuff is kind of hard to look at because they don't open all of their like documents. So like trying to find the sketch or a layout of their robot with the cage and all that is kind of tough to find. But the main thing that I went off is I looked at a lot of their like photos and looked at closely at their intake plate and tried to replicate it the best I can. And then I just put it all in this master sketch and just modeled the cage and modeled the different positions of the intake to show that we should be able to just take in the cage and climb.
Well, where we stand on some of these parts? How much have you had search of Lamar's stuff?
I think I have some of the elevator parts. We're gonna need probably more. The thing I'm confused about is are these like Thrifty bought elevator gussets. I think we should have bought 2 gusset kits, but I haven't like seen them, or I haven't like physically seen them or held them, so I have no confirmation on those. I mean, motors, if we wanted to, we could try to find a more powerful motor. The pulley we may have one lying around in Lamar. I mean, it's just a Vex Pro pulley, so we can probably find that. And then the belt is just an open-ended HTD5 belt. So we would get like one or 2 spools of the 15 millimeter wide belt, and we would just cut it as we need. And this is the one that Spectrum used.
Pretty cool.
Yeah.
So what is the part you want to build first? Because I saw you build
Um,
the intake, right? Or mock of the intake.
yeah. So we assembled like a mock-up version of this end effector at Westside within the past couple weeks, and we found that it actually held algae really well. Um, the coral was also pretty good. It was just whenever we intake the coral, it was kind of wiggling a bit. So um, I tried this, but realized that probably wasn't very smart. What we could do is just add sort of spacers here on this churro, just so it's kind of more snug, but it's not frictiony. Because if you look at the videos, the coral was extremely wiggly. Now, I don't know how much that matters, but I would assume that if it shakes too much, it'll just flop out. I did try to add 4-inch wheels on the corners here, but that made it too hard to intake. And either way we wouldn't. I realized after we wouldn't have the space for it since we needed to run the pulleys. So
What did you cut the plates on? Or the polycarb CNC plates?
we cut them out of acrylic because
Okay.
that was all we cut them on the laser at Westside, so it was acrylic.
So there's a good chance. Well, then you're gonna have to recut them anyway. So you could just
Yeah,
adjust the spacing
yeah, you can redesign it.
with a little tighter tolerances. I think that's
Yeah.
smart because we've realized after testing this sort of stuff that the wheels start to have a lot of give after a
Hmm.
few repetitions. So even if it is a little tight when it first starts, it'll kind of work its way in. So compared to wiggling, you can't. There's not much you can do once it's too loose. So
Yeah.
cool. So I know we're missing some parts, but schedule wise, where are you kind of thinking you want to be to have some of this stuff built out?
So I think we have to define what we want to get done by when is a big thing. Because I know we discussed like I don't think we can get this built by TRI, just because we only have like 2 or 3 weeks left, and we've seen from the past trying to make a robot that quick just won't end well. So I think a good goal would be try to at least get kind of like finalize the design with this A, and then try to like order parts, find and order whatever we can, so that when we get to TRI, we can still focus on the competition robot, but we may have something to bring to like the practice field, whether that is the drivetrain or this lift assembly. I argue we should probably try to do the lift assembly just because the drivetrain is, I mean, it's just a standard like max swerve. So we've done it in the past, but this is something new. And even if everything goes wrong, we can at least say that we tried to make a lift instead of trying to dump more of our resources into like a drivetrain. So so I think we can probably get this done by remix because that's in a couple months, and we should have enough time to like order parts and meet and assemble stuff and test stuff, and we should be able to compete by remix is the hope. But yeah, that was my thoughts on it.
I like the idea of the lift, where just do a full test of the lift. If we're happy with it, then we continue on. If we're really not happy
Yeah,
with it, then we might have to slow down and do something else. So
right.
yeah, I think it's fine. I mean, we need to motivate some more people to get involved in this building process. But I say we just start building and everyone gets some experience. And if this lift is coming together, we got all the people assembled at TRI. I mean, we could be working on our pit, putting together a practice lift, and while we have the time there and the tools, it might be worth it. So cool.
Yeah.